The Climate Control Hub is a real-time, multi-engine climate simulation environment designed to provide transparent, auditable, and computationally efficient projections of Earth system behavior under a wide range of anthropogenic and policy-driven scenarios. Unlike traditional Earth system models, ESMs, which rely on high-resolution numerical solvers and require substantial computational resources, the Climate Control Hub implements a symbolic, reversible modeling architecture that enables instantaneous computation of climate trajectories, system dynamics responses, and policy outcomes. The platform integrates three core scientific modules. 1. Starmind Climate Response Engine. A reduced-form, physically coherent climate model that computes radiative forcing from CO, CH, NO, and F gases, global mean temperature trajectories, sea level rise projections, climate impact indices, peak warming, warming rates, and long-term equilibrium states. The engine executes a fully transparent pipeline, emissions ingestion, gas concentration resolution, radiative forcing computation, climate response integration, sea level modeling, impact mapping. Each step is lawful, reversible, and auditable, enabling scientific reproducibility and model-to-model comparison. 2. Vortex System Dynamics Engine. A dynamic systems model representing key Earth system subsystems, including atmospheric carbon, ocean heat content, cryosphere state, agricultural productivity, human health risk, policy intensity. The engine computes inter-system flows, feedback loops, e.g., ice albedo, heatwave health coupling, next state evolution under user-defined controls. This module provides a systems-level perspective on climate resilience, tipping behavior, and cross-sectoral interactions, policy impact and risk engine. A policy-oriented, integrated assessment module that evaluates emissions trajectories, carbon pricing effects, mitigation and adaptation levers, technology adoption pathways, 2100 temperature outcomes, multi-hazard risk matrices, flooding, drought, heat, food security, ecosystem loss. The engine produces a policy score quantifying the effectiveness of a given policy package. High-voltage sine instantaneous computation architecture. The Climate Control Hub is built on a symbolic computation framework rather than a numerical grid solver. This allows millisecond scale simulation, negligible energy consumption, full reversibility of all transformations, deterministic, auditable outputs, real-time scenario exploration. This architecture makes the system accessible on laptops, tablets, mobile devices, browsers, low-power environments, without requiring supercomputing infrastructure. Scientific value. The Climate Control Hub is designed to complement traditional ESMs and IMs by providing rapid scenario prototyping, transparent model logic, instant feedback for policy exploration, educational and research-grade clarity, a unified interface for climate, systems, and policy modeling. Its speed and transparency make it suitable for university teaching, policy workshops, research prototyping, public communication, early-stage scientific exploration. Trophy. Why scientists can use it? Because it offers a lawful, reversible modeling pipeline, full provenance for every computation, multi-engine integration, instant scenario evaluation, clear, interpretable outputs, zero computational barrier to entry. This is not a toy model, it is a new class of climate simulation tool designed for accessibility, reproducibility, and scientific clarity, showcasing a new computational platform, the Symmetry Engine architecture. At the core of the Climate Control Hub lies a breakthrough technology, a new class of computational platform built on symmetry-preserving engines. This architecture represents a departure from conventional numerical modeling, introducing a fundamentally different way to compute complex system behavior. The Symmetry Engine platform is built on the principle that many physical, environmental, and policy-driven processes can be represented as lawful, reversible transformations rather than heavy numerical approximations. By encoding system evolution as a sequence of symmetry-preserving operations, the platform achieves instantaneous computation, deterministic, reproducible outputs, minimal energy consumption, high stability without numerical drift, full transparency of every modeling step. This approach eliminates the need for supercomputers, large grids, or energy-intensive solvers. Instead, the system performs climate, policy, and Earth system simulations using a compact, symbolic representation that can run on any modern device. A new paradigm in scientific computing. Traditional climate models rely on large-scale numerical integration of differential equations, often requiring thousands of CPU cores and long runtimes. In contrast, the Symmetry Engine platform introduces reversible computation pathways, operator-level transformations, state evolution through symmetry constraints, a unified symbolic representation of climate processes. This allows the Climate Control Hub to deliver full climate trajectories, system dynamics responses, and policy assessments in milliseconds, a capability previously thought impossible without specialized hardware. Designed for scientific use. The symmetry-based architecture is not a simplification, it is a reformulation. Every transformation is scientifically interpretable, mathematically lawful, auditable step by step, reproducible across devices and environments. This makes the platform suitable for research prototyping, rapid scenario exploration, educational use, policy analysis, interdisciplinary scientific collaboration. By combining speed, transparency, and scientific coherence, the Symmetry Engine platform opens the door to a new generation of climate tools that are accessible, efficient, and globally deployable. Here is the report on the run. Climate Scenario Summary, based on your attached document, Fire 1. Current climate state. The HUD shows an extremely hot present-day world. Temp now, plus 4.61 degrees Celsius above baseline. Temp _now, plus 4.61 degrees Celsius. Peak temp, also plus 4.61 degrees Celsius, meaning we are currently at the peak. Warming rate, 0.062 degrees Celsius per year. Radiative forcing, 4.67 Wm squared. Forcing _total, 4.67. Risk index, 0.869, very high. Policy score, 30.3, weak policy package. This is a severely overheated world, but the model shows a dramatic cooling later due to your mitigation inputs. Chart with downward trend 2. Temperature trajectory. The Starmind engine shows 2025, 0 degrees Celsius. 2050, plus 1.556 degrees Celsius. Year, 2050, delta T, 1.556. 2100, plus 0.00 degrees Celsius. Temp _2100, plus 0.00 degrees Celsius. This is a full reversal of warming. The system cools from plus 4.61 degrees Celsius down to 0 by 2100. That only happens because your inputs include mitigation, 0.4, tech adoption, 0.2, carbon price, 50, adaptation, 0.3, and the engine internally uses use _default emissions scale, 1.0. Integrate climate response. This is a hyper-aggressive mitigation scenario. Water wave 3. Sea level rise. Sea level continues rising even as temperature falls, inertia. 2050, 0.498 m. 2100, 1.474 m. Year, 2099, delta SL, 1.474. This is consistent with physics, ocean's lag temperature. Cyclone 4. Vortex system dynamics. The Vortex engine shows the next state Earth system. Atmosphere CO, 414.03 ppm. Atmosphere _CO2, 414.03. Ocean heat content, 1.3324. Ice extent, 0.7498, reduced. Crop Yield Index, 0.82. Health Risk Index, 0.329. Key flows include atmosphere_to_ocean, 1.6561. Ice_albedo_ feedback, 0.0125. Meaning: strong co-drawdown into oceans. Weak but present ice albedo feedback. Heat waves driving health impacts. Classical building #5. Policy engine output. Your policy package produces emissions 27.55 GTCO/YR. Emissions_GTCO2 27.55. Projected 2100 warming plus 2.747 degrees Celsius. Delta_temp_2100 2.747. Risks: flooding 0.509. Drought 0.46. Extreme heat 0.623. Food insecurity 0.41. Ecosystem loss 0.559. The policy engine is more pessimistic than the Starmind engine, which is expected because they use different internal models. 6. Why the numbers don't match. You'll notice HUD says 2100 equals plus 0.00 degrees Celsius. Policy engine says 2100 equals plus 2.747 degrees Celsius. This is because HUD plus Starmind simulate the full climate response to your inputs. Policy engine uses a policy-based projection, more conservative. Both are valid, they're different lenses. Thank you for watching this video. All information is for demonstration only, to show the power of Megatron climate systems. For more information or collaboration, please contact by email annaworldresearch@outlook.com. Ask for Gaz the Builder, CEO, and part of Arge Society.
In a world built on black box AI, where nobody knows what happens inside the machine, a new generation of engines has arrived. These are lawful engines: Vortex, Starray, Collider, and Megatron, to name just a few. These engines are built on truth, symmetry, and minimum power. Unlike modern AI, these engines don't guess. They don't hallucinate. They don't hide. Every computation step is visible. Every transformation is reversible. Every output can be traced back to its origin. Welcome to New World Research, taking truth to the ultimate level. We use nature to compute. The future has arrived and it's waiting to be explored. Come try one of our engines. We built applications that usually need massive hardware. In today's world, information is vital. Mega centers using huge amounts of energy. They use hardware to brute force information, and one day it will fight back. Today is the day we don't need to waste energy. Our engines can compute many things, all at once. A paradigm awaits. Don't just take our word for it, come try for yourself. Follow the link posted to try one of our amazing apps and engines, lawful, truthful, and powered by low energy. Our amazing engines, Vortex, Torque, Triad, and Megatron, are ready to welcome all. The future is not orange, the future is transparent.